Multiple sclerosis or MS is an incurable disease, so it affects the central nervous system, and sometimes it can take several years up until they find the right treatment, diagnosis, and prognosis. And that is just not good enough. So, our target as a team within this Flanders AI research program is to develop AI tools to speed up this identification of the right treatment for the right patient. And we do this by focusing on three main clinical challenges. First of all, we want to know which treatment is the best. So we aim to develop decision support systems for relative treatment effectiveness in what we call a real world setting. And then we come across all these challenges. MS is very heterogeneous. There is a high number of disease modifying therapies. There are so many confounders, and it is a very slow disease. And then on top of that, the data that we use is featured by irregular sampling, missing observations, different types of variables, and noisy measurements. In the next challenge, we actually want to identify very fast if the treatment works. And when we talk to neurologists, they say, it feels like I'm missing out on something. And it would be great if you would see it sooner. And that's why we aim to identify new biomarkers. And we believe that there are some new kids on the block, which we refer to as radiomics and apomics, which are high dimensional features in MRIs, as well as evoke potential time series. And then finally, the next clinical challenge is that we want to scale up, because there are currently many data sets already available, but it is very difficult to work with them because the heterogeneity between those registries is high. It is very time and effort consuming to harmonize them. When we want to do error detection, we continuously have to interact with domain experts, and usually then we still miss errors. And the most importantly, ethical and legal challenges obstruct us to actually speed up.